and welcome to a special edition of The Sky at Night. We're going to concentrate upon meteors, what they are, when to see them, and how to observe them. Now, I'm sure most people have seen shooting stars, but not everyone knows what a shooting star is. Well, it certainly isn't a star. It's a tiny particle, a bit of debris left behind by a comet. A tiny particle no bigger than a grain of dust. It dashes into the top part of the atmosphere, travelling very quickly, rubs against the air particles, and burns away in the streak of light we call a shooting star. And that is all a shooting star is, a tiny particle burning away in the Earth's upper air. Now, these meteors may appear from any direction at any moment. We call these sporadic meteors. But we also have well-defined meteor showers when we go through the trail left behind by a comet. Now, every August, we go through one particular trail, and the meteors there seem to radiate from a point in the constellation of Perseus. So we call these the Perseids. This year, we thought they might be well seen as there was no moon. Therefore, with John Mason, I went into the garden, looked up at the sky, and wondered what was going to happen.
Well, the Perseids, of course, are one of the best showers of the year. They're connected with a periodic comet with the name of Swift-Tuttle. It was last seen back in 1992, and it goes round about every 130 years. Now, the comet is long gone now, and it won't be back for another 115 years. But, of course, along the trail of the comet's orbit, there is a lot of dust. The comet, of course, the only solid part of a comet is the dirty, icy nucleus, probably 10, 20, 30 kilometres across at the most. And when this is closest to the sun, it's throwing out dust and gas, and this produces the head of the comet, the fuzzy coma, and dust and gas then produces the lovely tails. Now, as the comet goes round the sun, it leaves a dusty trail behind it. And over many, many orbits, thousands of years, it eventually produces a loop of dust all the way around the comet's orbit. And that means that even though the comet is nowhere near the Earth at the present time, when the Earth is in the right place, at the right time, intersecting the comet's orbit, those dust particles will be pulled into the atmosphere and we will see the Perseid shower.
But there are many comets going around the sun in this way, and they leave tails. There are many annual showers.
There are indeed. Halley's Comet, for example, is connected with two showers, the Eta-Acarids in May, the Orionids in October. We have the April Lyrids connected with Comet Thatcher. We have many, many others. And, of course, we also have one particular shower, the Geminids in December, which is not connected with a periodic comet, but which is connected with an asteroid, 3,200 Phaethon. Now, maybe that's an extinct comet nucleus, but there is a certain difference between the meteoroids, the dust grains that produce the Geminids, and those which are producing the Perseids that we see tonight. The ones we see tonight are of lower density, definitely cometary origin. The Geminid meteoroids are denser, more rocky material.
I think one thing is important, John. We have things called meteorites. They're large things that come from the sky, land, and may make craters, but they are not in any way connected either with comets or with meteors.
No, they're not. Meteor showers, of course, are caused by dust particles from periodic comets being pulled into the atmosphere. They're burning away very high above the ground, and no solid fragment goes anywhere near the lower atmosphere. Meteorites, of course, are caused by chunks of rock, mainly from the asteroid belt, much harder, much more durable. They may survive the fiery passage through the atmosphere and actually reach the ground. But as you say, meteors, meteorites, completely different things.
Well, we'll talk about the radio work later on, and we do have two radio astronomers here. But meanwhile, tonight it should be good. A cloudless sky and one of the best showers of the entire year, the Perseids. There's quite a gathering down here at my observatory in Chelsea. So let's now go and join Chris Lintott.
August the 12th every year, the night of August the 12th, is the peak of the Perseid shower. Tonight, that peak is forecast for between 5 and 7:30 in the morning, just after the sun rises. But there'll be plenty of meteors all night long. Now, Perseus is rising in the north over here, which means the best place to look is up here, about 60 degrees away or so, away from the radiant of the shower. And we've got plenty of people about ready to watch the meteors, plenty of cameras, and the telescopes, well, they're just here to provide a mount for those cameras. Now this is an antenna which tells you that we're doing something we haven't done on the Sky at Night for ages. If you watch the guy rope, this is radio astronomy, and with me are Andy Smith and Dave Entwhistle, And they're already looking at the Perseids. So, Andy, what are you planning to do this evening?
Well, what we're hoping to do is to detect meteors through the use of radio. And this is an activity that can be done in cloudy conditions or in the daytime as
So
well.
we're already looking at the meteor shower right now?
Absolutely. It's not dark yet. The visual people can't see very much yet, but we're already seeing meteors.
Andy and David aren't trying to pick up the meteors directly. Instead, they're looking for reflected signals. The antennas in Patrick's garden are tuned to a French television station, and signals from its transmitter bounce off the trail left by the meteor in the atmosphere, allowing them to be detected down here in Selsey.
The atmosphere above us is actually illuminated by the transmitters from across Europe. So the television transmitters in Europe are already switched on, they're broadcasting and they're illuminating the atmosphere above us. As a meteor enters that atmosphere, it actually reflects a signal down to the aerials that we've got on the ground.
And we can actually listen to that. So if we turn on this equipment, then let's have a go. So this is live, what Belgian and French television transmission sounds like. And then what should we be listening for if a meteor goes ahead?
You hear a Doppler shift of the head of the meteor coming straight through the atmosphere, and that sounds like a rapidly descending tone. And sometimes, shortly after that, is a continuous tone which comes from the trail of the meteor.
So this is when you have a large meteor and it leaves behind particles on long
The ionisation is strong enough to actually reflect that signal for a long time sometimes.
So have you picked any up so far this evening?
Yes, we have. If you have a look at the screen there, the vertical lines are actually reflections from the meteors.
All right.
Because we're operating over quite a short baseline between the transmitter and receiver, we're also seeing the curved reflections are from aircraft, but the vertical lines are actually reflections from meteors.
So a couple there already, and
Yeah.
presumably you can monitor the rate over the days leading up to the shower as well. Have you had a look in the last couple of days, Andy?
Yes, the meteor rates have been, I'd say, a little bit quiet compared to normal. But you'd normally expect to see the meteor rate increasing steadily night on night as the meteor shower increases.
Well, let's hope they pick up for later tonight. We'll come back and see how you're getting on. The importance of radio observations is that they can be used to monitor activity day and night, regardless of the weather. We already have the whistle of radio detections in the background, but the sun is setting, and so the visual observers are getting ready to capture the night's crop of meteors.
Not for the faint-hearted, astronomy at all. You need to be physically fit and strong. So we're set up now.
Well, it's a lovely evening. The sky is still clear. No wind. We await the meteors, but not quite dark enough yet. So let's talk to one of our great scientific historians, Dr. Allan Chapman. Welcome, Allan. Of course, the idea of meteors goes back a long way.
It's always a great pleasure to see you, Patrick. Yes, it's a very ancient idea. In fact, the term itself, meteor, really comes from Greek, meaning things seen in the air.
Yes.
And Aristotle spoke of shooting stars in about 350 BC. Now, over the centuries, people speculated about what may cause them. Were they caused by stuff spat out of volcanoes? But then, in 1794, a German by the name of Ernst Chladni made the first serious suggestion that there was matter coming in from space. And in the early part of the 19th century, the first asteroids were discovered. And then the new idea being, could they be the detritus of asteroids or comets?
Comets, of course. And we come on now then to our friend Sir Robert Ball.
Ball himself was one of the first people to really confirm the periodicity of meteors, because the Leonids had been observed brilliantly in 1833. Now, this meant if there was going to be another great storm 33 years later, and Ball observed for this, and his description of the meteor storm of the 13th of November, 1866, is one of the classics of literature, where he speaks of this great storm blazing out of the sky, and the sky being on fire. But also, too, of course, Robert Hooke in the 17th century had suggested that comets may be formed by somehow objects entering a corrosive burning area around the sun. And the analogy, he invented an experiment which is very similar to the way in which meteors enter the Earth's atmosphere.
Can you show you what that experiment was?
Do you know, Patrick, it's surprising you should ask that. I have all the ingredients on that table.
What's the coincidence?
Well, they may not work, but we'll try it.
We'll try it.
Now, in 1664, Robert Hooke tried to reconstruct how a comet burned. And he thought a comet burned by entering a corrosive layer around the sun and hence dissolving to give out great, great streamers. And of course, it's exactly what happens when a shooting star comes into the Earth's atmosphere. Now, what he does is this, and this is brilliant English experimental genius. He says, first of all, I took a wax ball and rolled it in filings of fresh iron. And that's one rolled in filings of fresh iron. He then says, I took a cylinder, 2 feet tall, he mentions, containing strong sulfuric acid in a 1:4 dilution. And when I put it inside it, it began then to corrode the ball away. Think of this as the layer around the sun or around the Earth, and this is a body entering it. Now, we can't use the original experiment because it involves acids, and sadly, health and safety say we're not allowed to use them. What we've done, though, is devise an alternative. Here's a wax ball coated with bicarbonate of soda in wine vinegar of 1 part to 4 of water. And I've never done this before. It may not work.
Let's hope.
But let's hope it gives off a bubble train, and that bubble train would be analogous to what Hooke draws as coming from a comet or from a meteor. Now here goes. 1, 2, 3. Look at that, and think of that as something flying through space, entering the corrosive area around the sun or around the Earth and burning up. And a 17th century experiment brings the point beautifully over to us today.
Congratulations, you are the modern Robert Hooke.
Thank you.
Thank you very much, Alan.
Thank you, Patrick.
Oh, there is cloud, isn't there? Yeah, there's not some cloud there.
Oh, that was a nice one.
Well, Perseus has risen, it's dark, I've already seen my first meteors of the evening, so we're using an infrared camera to avoid disturbing the observers. So let's see how they're getting on. So Bruce, how's it going? Have you seen many meteors?
Well, it's early yet, Chris. Just getting set up and getting ready for the show.
There was one, a small one anyway, but
Oh.
You've got a giant telescope. You can't see meteors in a telescope.
No, it's just acting as a platform for the camera to ride on to track the sky.
Obviously missed one there. Sorry, but yeah, so you're using your camera. Hopefully that got it. So how are you using the camera? Because this is just a digital camera.
It is, but it's got a really wide field of view. It's got a wide-angle lens, and I'm just taking as much of the sky as I can and hoping to capture some meteors.
So how long are you using as an exposure? Because this is something you could do. The lens helps, but you could do this with any digital camera.
You can. The wider the field of view, the better. Up at a high ISO speed of 1600 speed, and 30 seconds roughly for exposure time gives you a nice sort of vista of the sky and hopefully capture a meteor in the same time.
And just keep clicking away and hope you get lucky.
Absolutely.
How do you pick where in the sky to point? Does it matter?
Well, it seems to be wherever I pick, there isn't a meteor. At the moment, I'm taking the Milky Way through Cygnus, through to Cassiopeia, and it's so beautiful up there tonight. I'm just hoping that I'll capture one in that area.
And the point is not to point directly at Perseus. Even though these are the Perseids, you don't look straight at the radiant.
No, I find about 45 degrees from the radiant seems to be the ideal sort of position. Anywhere 45 degrees from the radiant in Perseus will give you a good long meteor.
Okay, we'll keep clicking away. We'll catch up later.
Thanks.
There was one, a faint one, you see it?
No, I didn't. I was looking down at that moment.
That was a Perseid, all right.
Damien, what have you spotted so far?
I've seen several bright meteors. Yeah, it's progressing nicely. We've got a fantastically clear night. The conditions are absolutely perfect, so I think for later on when the radiant gets up a bit higher and the activity increases, we should be in for a real show, hopefully.
Sure. And we should see more after midnight anyway, of course, as the Earth rotates around.
Yes, absolutely, absolutely.
Oh, and there's a nice Perseid there.
I understand, looking away. One thing we've not seen tonight, at least I haven't seen any really bright meteors, and certainly nothing in the nature of a fireball.
No. Now, of course, a fireball is just the name we give to any meteor that's brighter than mag -5. In other words, brighter than the planet Venus at its best.
Oh, yes.
And the brightest meteor I've seen tonight was about -1. So we've certainly, as you say, seen nothing in the fireball class. And the interesting thing is that very bright Perseid was probably caused by something that was smaller than a pea in size. But because it's travelling at such enormous speed, 135,000 miles an hour, as it dashes into the atmosphere, it produces that really bright bright trail. And of course there was a persistent train as well, which is where you get that just faint wake left behind the meteor after the main parts disappeared.
Well, John, it's early in the evening, but have you had any luck yet?
A little bit. I've seen one or two of the smaller meteors, and a couple which I think are almost what's termed the fireballs.
Yes, the really spectacular ones.
That leave a trail. A couple of those, but you do get a sense it's starting to build up and up and up, ready to that time when everything peaks.
Yeah, and those fireballs, if you do see one, it can stay with you for years, can't it? You don't quite forget them. Have you ever seen anything really spectacular?
Yeah, only just a few months ago in Lancashire, actually, quite by surprise. Just walking along and then there was this, it sort of took your breath away, made you jump.
Yeah, and you certainly think you hear the sound, even if, I don't know, they can make sounds, but they should do. There should be that sound effect.
I think your imagination fills that sound in.
Some of the very brightest fireballs are actually meteorite droppers, of course. Not the sort of thing we're likely to see tonight, but I mean, I remember did you just narrowly miss the Bovedi meteorite of 1969?
I've been out observing Saturn, I think it was. I just come in for a brief break and a cup of tea, and the thing shot across.
What rotten luck. I'd love to have seen that.
I said, tut, tut, how annoying, and things like that.
Oh, there's a swift Perseid in Pegasus.
I've never watched the skies in the company of so many people, and that makes it far more fun.
Although, like you say, every time I hear a cry go up, I think that's another one I've missed.
Yeah,
and having the radio in the background's quite fun, isn't it?
Oh, yes. As soon as you hear it go bong, you want to see what it is.
Yes. Watching meteors is a chance to contribute to science with nothing more than your eyes. Recording the progress of the shower allows us to map the distribution of the meteor particles, and this is the key to uncovering the history of the comet they came from.
In a lot of them, it's just amazing how meteors seem to come in clumps. Yeah. 3 or 4 straight away, and then a long lull, and nothing happens at all.
It's one of those things that most people notice when they're out observing, that you get 2 or 3 happening together, perhaps within a minute, and then a period of several minutes when there aren't any. And this is why you can get people going out and saying, oh, I stood out for 10 minutes and didn't see any, and someone else will say, well, I stood out for 10 minutes and saw half a dozen. Where was that, Ian?
In Cepheus to Cygnus.
Oh, right.
I missed that one.
Down the axis of the Milky Way, nicely.
Well, you're using some quite advanced equipment. What are you using, and how are you getting on?
I've actually been using an image intensifier which I bought about 18 years ago from the States. These are extremely sensitive. They can amplify light by up to about 50,000 times, which in real terms you perhaps get about 2 or 3 magnitudes better than you can do with video.
So in terms of technology, this is similar to night vision goggles?
That's right, yes. Yeah.
Have you had any particular luck this evening?
The very bright fireball we saw just went through the corner of my recording.
They're always just through the corner.
That's right, yes. You can certainly see it was extremely bright, yes.
And you say you've been doing this for, 18 years?
Yes.
What are the really particularly memorable nights?
The unexpected Leonid fireballs in 1998. I just happened to be out recording on the right night that night, and captured about 70 or 80, but nearly all fireballs, so that was fantastic.
Oh, there's a nice a sporadic there in Andromeda coming up from,
I saw that way, yes.
coming up from Aquarius direction.
Of course, the bright thing you've seen tonight, of course, is the International Space Station. That went over beautifully.
That was superb.
And that really is bright, of course, now.
Yes. And, of course, the Space Shuttle Endeavour is docked with it at the moment, and it made a really brilliant, it must have been nearly -3 when it went over.
It was more than that, John.
Yeah, it was fantastic.
I think it was much brighter than Venus. I think it was near -5, I think.
Several times this evening I've looked up, seen a bright meteor, and then heard a whistling from the other end of the garden. And that whistling's coming from this antenna and its partner, which make up our radio astronomy experiment. So, let's see how David and Andy are getting on. It's now reasonably late. Perseus is high in the sky. So what results have you got so far? Plenty of meteors, I can see that.
That's right, yeah. We've seen the rates gradually build from earlier on in the evening when the radiant was low down in the north. The rates have steadily built up as far as we can tell. But there was a prediction for enhanced rates about 2245, around about that time, and there seems to be some evidence, looking at it first glance, to support that view.
And this picks up filaments in the trail from the comet, so we're not just passing through a uniform cloud of dust.
That's right, yeah.
Andy, I heard a ping just then, so that was a meteor.
Yes, we just heard the Doppler shift from the head of a meteor plunging into the Earth's atmosphere.
And that one I can see on the screen is just a simple spike, but you've had some really spectacular ones this evening already.
Yes, we've had some quite long reflections which have lasted for several minutes.
Well, let's have a look at one of those, and you can see all this structure in it. You get the initial peak and then all of this. So what does that mean? I mean, what's that telling us, especially those... Oh, there's another one, and it sounds like some people saw that one as well. Although I didn't, I was looking down. And you can hear there, that's going on for quite a long time.
Yes, so that was quite a strong trail on that meteor, which is continuing to reflect that signal.
So what does that tell us, that that's surviving? That was a particularly large meteor? Or?
If you had visually observed it, it could well have been quite a large fireball.
Well, it certainly sounded like some people saw something. There's still noise going on there. Is that another signal?
That's yet another meteor there, very strong one.
Fantastic. A couple of the meteors I've seen tonight have shown colours. I saw one blue and one definite yellow meteor. The key to understanding this lies in their chemical composition.
It was discovered in the 19th century that when certain chemical substances are burned at intense temperatures, they emit particular colour signatures. Now, if you take something like common salt, which contains sodium, you find it always produces a brilliant yellow flame. Scientists came to realise that if they see this yellow colour anywhere in the universe, sodium must be present. Likewise, if you burn potassium nitrate, you get a lovely mauve flame. And copper sulfate.
Oh, yes.
Beautiful green colour. Now, of course, it doesn't always mean that when you see a colour in the sky, such as, let's say, in a meteor or in a large fireball crashing through the air, grander and even bigger than a meteor, that the colours are always the same as you see here. Because we know in the laboratory that you have transitions, as they're called, so that a colour seen in the heavens is not strictly always the same as we see on Earth. But with sodium, it always is. So if you see a great meteor or a great fireball and it's spitting out gorgeous sparks of bright yellow, you know there's sodium in it. And this is a wonderful way in which you can apply laboratory physics and laboratory chemistry to astronomical bodies. And that was a major part in our growing understanding of what the universe is made of.
Well, let's look out today for yellow meteors.
Well, Brian, looking at the night sky like this must remind you, you did a lot of this 30 years ago on, what, Tenerife?
I did indeed, yes, and looking for the zodiacal light and seeing the occasional meteor and a wonderful black sky in Tenerife, of course, in the centre of the island.
Sure, let's talk about that a bit. What is the zodiacal light? What does it look like in the sky and what causes it?
Zodiacal light, if you're lucky, is a beautiful cone-shaped diffuse patch of light. It looks a little bit like the Milky Way, but more even and more diffuse. And you can see it in the west after the sun's gone down and twilight's disappeared, and in the east just before dawn. Again, you have to be lucky and you have to have no clouds and no moon, and preferably be in the tropics, because then the ecliptic is pointing quite far up and the zodiacal light lies along the zodiac.
The fact it's along the zodiac says it must be something to do with the solar system, right?
Yes, it's dust in the solar system. We're looking at a few microns in size, I suppose, with these meteors. There are a few microns, aren't there?
So about the size of a sand grain, I would guess.
Yes, but the zodiacal light probably is caused by much smaller particles of a micron or less, a millionth of a metre or less.
So if these are smaller particles, could they have come from the comets, just like the meteors that we're seeing this evening?
Yes, I think current opinion is that probably about half of the zodiacal light is due to cometary debris, like we're seeing here, but smaller, and the rest of it, or most of the rest of it, is probably due to the breakup of asteroids.
Oh, meteor.
See, my finger was not on the button, but we did see that one. But if I point my camera at an area of the sky, it's guaranteed there will be no meteors. That might be a useful thing to...
Yes, you should investigate that. There's some new physics there somewhere.
Yes, yes.
Excellent. It always feels like you miss the best of the meteors, but Brian was lucky. By combining several trails on the same image, it's possible to identify the position of the radiant on the sky.
Well, Alan, how's it going? Have you seen many?
Well, I've quite a few actually. Yes, there's some beautiful ones a few moments ago. Dropped straight out of the square of... there's another! There's a corker, a lovely one.
Oh, look at that one! It left a nice persistent train.
Yeah, that was a Perseid, all right.
Yeah, it certainly was.
Must be quite fun sitting with your several hundred images and flicking through. And I presume you can see meteors you missed on the night.
Oh, absolutely. I mean, when you go home tired after a meteor session, the last thing you want to do is actually work through all those frames. But you invariably find yourself doing just that, and you sit down, and it's very very addictive to sit there to see if there is a meteor on the frame. And then occasionally you'll get that really bright meteor going across the image, and that is absolutely fantastic. When you see that, you know, the hairs go up on the back of your neck and you know you've got a fantastic shot of a meteor.
You may be lucky and spot a meteor on any clear night, but keep an eye out for the most active of the showers. The Perseids in August, followed by the Orionids in October, the Leonids in November, and my personal favourite, the Geminids in the cold nights of December. All you need is a dark sky with the moon out of the way, enough time for your eyes to get adjusted to the dark, and just a little luck.
The brightest part. So, 2¼ hours, 2 for 3 for 4 for 5 for 6 for 78, 49 meteors.
Well, it's, what, 2 in the morning. John, how are you getting on? How's it been?
Well, I've got terrible neck ache from looking up all the time, but it's worth it. When you see a great one, it's just wonderful. Some you see, some you miss, and then you hear other people calling out, "Whoa!" from across the way as though a goal has been scored.
Oh! But it's hearing the sound effects. I mean, they add to it in a big way, I think.
Yeah, it's a little sort of radiophonic workshop over there, isn't it?
Oh, look at that!
Where was that?
Just to the east of Polaris.
Just as I was talking, Papa.
Yeah.
There you go.
Missed that one. Yeah, Terry, how are you doing? Are you catching some of them in between?
I'm lying about some of them. I'm just going, ooh, anyway, on the basis that no one will notice. I've never, as it were, done astronomy in a crowd before and realised that it's almost a competitive sport.
Hopefully not too competitive. I think it's a friendly atmosphere.
Oh, absolutely. But yeah, I mean, it's been absolutely wonderful, and we have seen some fairly amazing ones this evening.
Well, we've had a very satisfactory evening. We haven't had a meteor storm, didn't expect one, but we have seen plenty of meteors, and there are always meteors to be seen in the sky, shower or not. It's been great fun, and 2 points I think come out of it. First of all, we've done work tonight of real scientific value. Secondly, most of the people here are amateurs, and that shows again astronomy is a science where amateur and professional meet. And so now, from my garden in Chelsea, the sunrise not very far off, and meteors still in the sky above us. From here, good night.